All right, thank you everybody for coming to this presentation, Strategies for Protecting Data Using Encryption in Amazon Web Services. My name is Ken Beer, and I work in the AWS Cryptography Services division. I have given a talk similar to this the past 2 years at reInvent. And so for those of you who have seen those talks, there'll be a little bit of review, but we've got some new and exciting information to share. We've also got a customer and partner from Adobe Systems, Frank Wiebe, that'll come up and talk a little bit about how they chose to implement encryption using AWS services. Okay. I'm pushing a button. Oh, there we go. Good. So what should you expect from today's talk? There are lots of options for protecting your data with encryption. There's not just a one-size-fits-all. So I hope that I can give you a survey of those different options. We'll dive deep in a few of them. And I invite you to come and talk with me after the presentation to learn a little bit more. And of course, there's plenty of documentation on the site. One of the areas I'd like to dive deep on is the Key Management Service, which is a new service that we launched here last year at reInvent. But I also want to talk about some of the other options we have. We have a service called CloudHSM, and we have partner solutions. And finally, Frank will come up and talk a little bit about how they're using the Key Management Service to solve some of their data security needs. So to set the stage for folks, just to understand what the problem space is and how AWS can help address it. In order to encrypt something, you've got to generate a key. In my example here, I'll use a symmetric data key. So this means the key to encrypt is the same as the key to decrypt. You combine that with your data, you have produced encrypted data. Now you can store that data really wherever you want because the security is attached to the data. Access control to the storage doesn't much matter unless you have the key. But of course, now that you've used this key, you've got to protect that key. And so what do you do with the key? Well, one of the best practices is to encrypt that key. And now I have an encrypted data key that I get to store alongside the data. So 2 pieces of ciphertext that I can store wherever I want. And in order to get to the plain text data, I have to unwrap or decrypt the symmetric key. And of course, we have a new problem, which is what to do with my wrapping key. Does anybody have any ideas on what we should do with it? Encrypt it, of course. Yes, we have invented the blue key. It is world-changing. No. So you encrypt it with another key, and you can keep doing this all day long. And this is what a lot of customers do and create a key hierarchy. At the end of the hierarchy, you've got to have access to a plain text key. It just doesn't work any other way. And so this is the fundamental problem that developers have. I can generate keys fairly easily with open source. I can apply them to data with open source algorithms. But now I've got to stick a key somewhere and understand where it is and what the security controls are around it. So as you're evaluating your encryption options, whether it's for on-premise solutions or data in the cloud, you need to think about some properties of the solution. First of all, where are these plain text keys actually stored? A lot of people like the idea of keys that are generated and stored inside hardware. Well, is this hardware that you own? Can you go and hug your hardware security module and you know exactly where your keys are? Or is it okay if this hardware is hosted somewhere else? What controls are in place around that hardware? Next question is, when and how are the keys used? So you may be comfortable with plain text root key material being protected at physical security, but you still have to make them useful to applications. So is the software, the application, the authorization, again, completely under your control? Or are you asking a service provider to encrypt using your keys? Who are the exact entities, the users, the applications that have permission to use those keys? How are those permissions modeled? What controls do you have to change those permissions? So these are things, as you're considering your own applications, go down this checklist and attempt to make a rough guess as what the answers might be. And finally, if you are delegating control of the physical security or the authorizations to use the key, what assurances do you have that the second party to whom you're delegating control is actually doing the right thing? So I'd like to talk about options for using encryption in AWS in two different contexts, one of which is what I'll call client-side encryption. And really what this means is your application produces some data, and the minute it's produced, it gets encrypted in an application space using client code that you control. In the context of storing that data in AWS, you would send us ciphertext. So all we see are encrypted bits. You may supply the encryption keys yourself, or you may be able to leverage encryption keys that are managed in some of the services that we offer. I'll talk a little bit more about that later. Today, we have some client implementations for S3, EMRFS, and DynamoDB. Now, this means that we offer the encryption algorithms and the APIs and the interfaces to make it simple to submit data, have it encrypted, it ends up in S3, Dynamo, EMR. But the actual keys, those are decisions left up to you. The other option is server-side encryption. Now here, you are submitting data to a service, and you're saying, before you handle the storage of this to persistent disk, you need to encrypt it for me. And in most cases, you're encrypting it, the service is encrypting it, using keys that it at least has access to. It may be managing entirely for you, or it may be sharing keys that you have yourself. So you're delegating the service to encrypt on your behalf at the server side. So this is a pretty popular method in AWS. Today, we have 9 to 10 services that support this model. S3 has supported this model for coming up on about 5 years. EBS introduced this a couple years ago. In the past couple days, you've seen announcements on the AWS Import-Export Snowball service, as well as the Kinesis Firehose service. As new services come into being in AWS, if they ever are responsible for your data, and there are security requirements around that data that require encryption, they will support an integrated way to manage those keys so that you have a unified view into who has access to the keys and therefore who has access to the data. Let me go back to client-side encryption a little bit and explain how this might work. So at this point, since you're essentially using the AWS SDKs, those can be resident anywhere. It may be in systems inside your own data center where you are extracting keys from your own key management infrastructure. Now, key management infrastructure may be as simple as, oh, I put keys in this directory. And hopefully it's not that simple, but it can be, right? Since we're just providing the SDK, we don't much care where those keys come from. But you apply encryption to your data, and then it's submitted up to the service. That same application code could be running on top of EC2 in your instance. Again, you connect to your key management infrastructure to pull keys. Ultimately, the AWS service that now has your data is just seeing ciphertext. And if you need to decrypt, you just reverse the process. So this is how this works with the Amazon S3, EMRFS, and Dynamo encryption clients. Server-side encryption. I'll talk a little bit about a nuanced version of this that S3 provides. So a little over a year ago, we introduced this concept of server-side encryption with customer-provided keys. So what our customers were telling us is, we still want to provide the key that encrypts this particular object, but we don't want to do the actual encryption on the client side. If you think about mobile applications, where I might not be able to run encryption software on the mobile application, this is where this makes a little bit more sense. So the model is, as a part of your S3 put, you also include 256-bit key inside the put. At the S3 web server, we then encrypt that data for you using that key to produce ciphertext, which we store in the back end, but we then get rid of that key. Okay? Which means the next GET request that you make of S3, you must provide that key. All right? So this is a model where you are on a object-by-object basis allowing AWS to do some work for you to encrypt, but you're not giving AWS any further access to that key until you need access to the data. This slide is going to be a little small for those in the back, but this is a screenshot of the interface for asking S3 to do server-side encryption. So this is the model where I send plain text, and S3, you just handle the encryption. I'm not supplying any keys, necessarily, as a part of the request. And there's a few different models here in the ways in which S3 can do server-side encryption. And the one that's in the bottom half of the red box there uses the key management service. So you're effectively saying there are keys in existence inside a service, and I want you to use this one referenced by ID. So let's talk a little bit about Key Management Service, or KMS. It is a managed service designed to simplify the creation, the control, the rotation, and the use of encryption keys inside your applications. It is integrated with AWS server-side encryption across a whole host of services, and this list will grow over time. It is also integrated with the SDKs, so if you want to do client-side encryption with S3, EMRFS, and Dynamo. Remember, all of those clients also allow you to supply your own keys from wherever they might be, but there's an option to have KMS manage the distribution of the keys. One of the powerful things about Key Management Service is that it is integrated with CloudTrail. So any access of keys inside the service will always emit an event that shows up in your CloudTrail. So now you can have proof of a particular piece of data was accessed, meaning decrypted, under this given key at this time and place. And I'll show an example of what that CloudTrail log looks like further in the presentation. The service is available worldwide in all commercial regions, except China. So this screenshot right here shows how we've integrated the console experience. It's actually a part of the IAM console. A lot of customers told us that the types of people that they want managing keys and giving access to manage encryption keys are also the same ones that create IAM users and roles and have the ability to change policies for users. And so it is often simpler to restrict access to that set of folks. You'll see inside the UI here in the table, there's a couple different types of keys. The ones at the bottom with the gold cube, we call a default service key. The way to think about this is a starter key. You want to encrypt data in EBS. I want to create encrypted EBS volumes. But I don't really want to think about creation of keys and management of policies and rotation. I just want to check the box. We will automatically create a key for you in your account that can only be used for EBS encryption. So you've now scoped down the use of that key, and that key is not shared across any other accounts. The keys that have checkboxes on them are keys that were created. And these keys, you create yourself, you define the policy on, you decide if you want it rotated on an annual basis. You decide whether the key is active or inactive, enabled or disabled. You have much more control over the use of that key. So let me describe how keys inside the Key Management Service get used by AWS services as well as your applications. So in general, we're using a two-key hierarchy whenever encryption of an AWS resource occurs, which means that for every resource, we ensure you have a unique data encryption key. That's every S3 object, or every Redshift cluster, or every EBS volume, so on and so forth. That unique key is vended to the service to use to encrypt your data directly. But we also vend an encrypted copy of that key to the service, and it's encrypted under a key inside the Key Management Service that you control. The important thing to remember is that the keys in KMS, the red key, if you will, in this model, you think of it as a master key. Those keys can never leave the service. There is no export API. There is no way to get plain text bytes of that key out. All you can do is ask that encryption or decryption operations happen against that key. So the data keys that are used to protect your EBS volume, for example, the plain text version lives in memory to encrypt your I/O, but there is an encrypted copy of it available for recovery situations, right? It's encrypted with a key, and the only way you can get to that key is passing it back up to a centralized KMS server. Now, you'll notice that the dotted line on the right-hand side, I've shown that in a custom application using the SDKs, you can submit data directly to KMS for encryption under a master key. All right? It's possible. In fact, one of the things that we've done with KMS is it's included inside our PCI shared responsibility report. So you can submit PAN directly to KMS for encryption. And that may be the faster and easier way for you to encrypt data rather than relying on envelope encryption and having to manage these ciphertexts of data keys that get returned. But in general, across AWS services, the advantages of this are that encryption happens very fast because it's local. You only have to manage a small number of master keys as opposed to the potentially billions of S3 keys that are created for every single one of your objects. And because access to those data keys must happen inside KMS, it's a central point where you get complete audit for all use of keys and therefore all access to your data. So now I'm going to drill down a little bit more about what happens in the case of services that are using your keys. Where is this material going? So this is a somewhat generic diagram where the orange box there has received a request from you to create an encrypted resource. Okay? It might be helpful to think about this as you are launching an EC2 instance and you want to attach an EBS volume. So in this case, the client calls to KMS and says, I need a data key that's unique to this resource. So generate data key is the API that's called. And I want that data key protected underneath a master key inside this customer's account. Okay? So you get to decide which master key is being used to protect a given resource. The request is authenticated both on the application that's making the submitted request using standard AWS IAM access keys and secret keys, but then there's an additional policy check on the key itself that says, is this client that's calling me allowed to use this key in this way? So in the case of EBS, the person who wants to create an encrypted volume, that person, whether it's a human or an application, must also have permissions on the KMS master key to make a generate data key request. So this is an important thing to remember, that encryption, we believe, is only valuable if you have independent controls on the authorization of the resource and the keys, right? You can't just encrypt for encryption's sake, and if I get access to the resource, we decrypt automatically. These are independent controls, which means you need to pay attention to who can use this key for certain actions and who has access to the resource. So, in this case of the EBS volume, we generate a unique 256-bit AES key that will be applied to encrypt all I/O to and from your instance and the EBS volume. We return that plain text, and we return the encrypted version of that key that gets used when you are ready to decrypt your volume in the future. So what does decrypt your volume in the future mean? Typically, it means I've created a snapshot, and I need to reattach that snapshot to another instance. So that snapshot is a bunch of encrypted data, and there's an encrypted data key. So now EC2 is going to pass that encrypted data key to KMS and say, customer X would like to be able to decrypt this in order to attach this snapshot to this instance. So you get a record of all of those actions inside CloudTrail, because everything has to come back to KMS for it to work. So the interfaces for how you select keys to ask a AWS service to encrypt on your behalf. I showed you a little bit of a snapshot of how this works inside the console. Think of a drop-down. Keys that you have created show up in the drop-down. You can define a human-readable alias if you want. You can also refer to these keys using their longer key ID, or ARN, if you're familiar with the concept of an Amazon resource name, inside the CLI or the SDK. And these values can be plugged into CloudFormation templates. So you can ensure that your administrators who are creating resources in AWS are always using the correct key to encrypt. So let's talk a little bit about the authorization model on keys themselves. So here's some use cases for how you might want to use this. So the simple one is to say, this key can only be used by this set of users or roles inside a given account. I may have a larger set of people who can write to this S3 bucket or create Redshift clusters or spin up RDS databases, but a much smaller subset are allowed to use this key to create encrypted resources or decrypt those resources. Another model is to say that this key can only be used by this user or application to encrypt, and they can't decrypt. Only somebody else can decrypt. So for those of you familiar with public-private key cryptography, you know that asymmetric cryptography is often used to deliver on that very use case. Given the fact that all encryption requests are coming back to a centralized service with authorization control, you can effectively get a lot of the value that public key gives you using permissions on encrypt and decrypt APIs. Another use case is to say, I only want this key to be used to decrypt data if I know that the is active, if my EBS volume is attached to an instance, if my Redshift cluster is up and running, if my RDS database is processing data. When I terminate those instances, I don't want this key to be used to decrypt the snapshots that I've got stored. This is actually how we implement all the authorization logic for AWS services to use your keys, because we don't want the services to be able to use a master key on your behalf to decrypt unless they know that you want them to. And the way we know you want us to do something is you make an API call to a service and you sign it with your access keys. The other thing you can do on KMS keys is to define what management actions certain people have. So some people might be able to create keys. Only these people over here can disable keys, or a special team is the only people that are allowed to modify policy on a key. So all of this is fully integrated with AWS Identity and Access Management. So for those of you who have been using AWS, I will assume you're very familiar with IAM. And all of the same semantics and syntax for the policies work just like this. So one of the big questions about encryption keys, how do I rotate them? So there's a couple different ways to rotate keys. When you are managing a key inside the console, it's a checkbox. It says rotate this key every year after its creation date. What happens with rotation? Because rotation, in most people's minds, means I've changed the key. Now all the data that was encrypted on that key, I've got to go re-encrypt it. That's not the way we view rotation. For master keys that are rotated, we will keep the old version of the key, but we ensure that it can only be used to decrypt previous data. All new encrypt requests against this key ID will use the new version, the rotated version of the key. We keep both versions around, but they both map to the same key ID or the alias that you've defined previously. So your applications don't have to know anything about rotation. It just works. And you can get evidence in CloudTrail that we rotated your key to make your auditors happy, but you don't have to change anything inside your applications. Okay, let's talk a little bit about how you can audit use of a key inside CloudTrail. So I've extracted kind of the relevant bits from a CloudTrail event. So this particular KMS API was called, which is the decrypt, at this time in reference to this key ID. So this is the 32-character GUID that we assigned to the key that we created on your behalf. It's guaranteed to be unique. This is the encryption context that's used to protect this particular resource. The call came from this IP address. And this is the user identity that made the call, the IAM user, the account, the role. So let me go back. My pointer doesn't work very well. Encryption context. What's this? This is not necessarily a standard concept inside cryptography. One of the problems with the two-tiered hierarchy is that our system typically only sees data keys, right? We want to decrypt an encrypted data key. So we get a data key, we decrypt it, we send it back. We have no real way of knowing what is that key used for. We might get a sense for it if we know the caller was, say, the Redshift service, or your, a server that's holding your EBS server, excuse me, your EC2 instance. But we can't really give you any authoritative statement on what that key is ultimately used for unless the caller tells us. Okay? And so what we do is we require all AWS services, when they first request that data key, to pass in this encryption context, which is an identifier of the resource. So that in the future, when you see decrypt events like this, you can say, oh, I see, this master key was used to decrypt this resource, in this case, volume ID 12345. This tends to be a pretty nice story with your auditors, because now you can complete the cycle from keys in my key management system were used to touch this specific resource, and I know this resource has PHI on it, or PCI on it, or whatever data is of interest to your auditors. And you can also build CloudWatch alarms or dump CloudTrail logs into your own SIEM systems and start to look for these encryption contexts to get a better sense for how your data is being encrypted. Okay, so I invite you to look at our documentation to understand what the APIs are. We have 26 of them now. I've thrown up some samples of management APIs versus data plane APIs. We think it's fairly straightforward. We'd love to have you take a look and give us some comments. Okay, here's an important question. With KMS, you've asked us to create a key. We create a key. We store that key. We put authorization controls on it that you control. What assurances do you have that we're doing the right things with your keys? So first of all, as I mentioned earlier, access to key material itself, the ability to take key material, use it outside the system to decrypt ciphertext I might be able to find, that's a real threat. We take that very seriously. And we have no tools in place to get access to raw bytes of your key. They don't exist. Your plain text keys, they have to get used to do encrypt and decrypt. They're only used inside memory. They're never written outside of memory in plain text. You have complete control over who can use the key because it's tied into the IAM system and the AWS authentication system. So that's how it's plumbed through. So you are responsible for defining policies. There's a separation of duties between the AWS service team that manages master keys and the teams that are actually managing your data and any resulting data keys. Okay? On the KMS systems that manage your master keys, we have MFN quorum-based controls to ensure that no single operator can even get access to a host that might have your key in memory. So don't just believe me, believe third-party audits. So these claims are inside our SOC 1. And as of July of this year, you'll see that the PCI DSS, specifically in sections 3.5 and 3.6 around key management and encryption, KMS meets all of those requirements so that you can submit PAN directly to KMS for encryption. How much does it cost to use KMS? There's two pricing dimensions. When you ask us to create a key, and it shows up in that table in the console or as a part of a response and a CLI request, $1 per version per month. And a version maps to rotation. So at the end of a year, if you have opted in to have us rotate it automatically, you now have 2 versions. So that's $2 per key per month. The other way that we charge for KMS is request volume. And so every time you make a request to KMS, whether it's via another AWS service or from your own application, there is a fee of 3 cents per 10,000 requests, but we give you the first 20,000 per month for free. So you might say, well, what does that mean if I create 500 instances with encrypted volumes? Well, I will say that when you go about creating an encrypted volume and mapping it to an instance, that's 3 API calls. Okay? So you can do the math. You're about 3,400 volumes above the 20,000 free requests before we start charging you 3 cents. So if you're just using this to encrypt volumes or databases or Redshift clusters, you're not going to see a lot of requests. Now, if you're using it to encrypt and decrypt S3 objects, where you might be making 1 billion puts per month and 2 billion gets, that can make a difference. So we have some pricing examples on our marketing pages that can help you walk through this. Okay, so we've talked about the key management service. I want to talk about some other options we have, because it's very clear from talking to customers that key management service appears to put a lot of, like AWS has a lot of control over the keys, right? If you're not quite comfortable with that, or you have some other regulatory or compliance drivers behind an alternate solution, what can you do? So let me talk about CloudHSM. So CloudHSM, the way this works is you get a dedicated device that is a hardware security module manufactured by a third party. And this device is located in our data centers, but it is dedicated to you. So we rack it, we give it power, we give it network, but you are now the administrator of that device. And as a part of being the administrator of the device, you have to create partitions and generate keys on that device. The interfaces to this device are not via AWS APIs. It's a different client, right? Different interfaces. So it's as if you're connecting to your instance and trying to do something on your instance, right? All of that is up to you. These are located inside Virtual Private Cloud, and there at the bottom, we're actually using the SafeNet Luna SA model of HSM, which is a fairly popular model. Some of you might have some experience with that. It's available now in 7 regions. And it has some interesting compliance validations and certifications. Specifically FIPS 140-2, Level 2. It's also been included inside our SOC and PCI DSS reports. So why would you use this? How would you use this? Go into a little bit more detail right here. We have some integrations with CloudHSM with a couple of AWS services, but the general way that people like to use CloudHSM is directly from software running inside their instance. And the reason is that you control the software, you control the authentication mechanisms to the HSM, and you control the HSM. So you have end-to-end control over the storage of the keys as well as the use of those keys. Because remember, with a hardware security module, once you've created a key, it cannot be exported from the device, and AWS does not have the ability to log on to the device. And the way these devices are built, if anyone tries to tamper with them, keys are zeroized. So you have higher assurance through the work that SafeNet Gemalto has done around the physical security of your keys. So from a diagram standpoint, the way this works is the CloudHSM is kind of the backing device. You may need to, well, you're certainly going to have some software that interfaces with that device. SafeNet provides lots of different options here. They've even got some integrations to make it easier to work with EC2 and EBS, as well as S3. I believe they're working on some things that'll make it work with EMR. But you are effectively managing the entire software layer from your application back to the HSM. So how does pricing for CloudHSM work? There's a one-time charge to get this device because it is a dedicated piece of hardware that we're racking on your behalf, after which we charge an hourly rate. You can see how this works for year 1 versus subsequent years. Unlike KMS, we don't bill you by request. We basically say, here's a device. Now it has certain performance characteristics. And so you're going to have to manage request rate to that device, and perhaps have multiple devices if you need higher request rates. But the devices tend to be pretty full-featured in terms of which cryptographic algorithms they support, which interfaces they support. These are products that have been in the market for, boy, as long as 20, 25 years in some cases. And so for those of you who work in industries that have been using HSMs, this should be very similar to what you're used to. Okay, so we've heard about two different options. How do I choose between these? So CloudHSM, dedicated access, validated by trusted third parties. You control all access to the keys. You control all availability, durability. You're responsible for a lot more in this case. You have more control. Your software interfaces tend to be custom. They're not really related. There's no AWS SDK that lets you use keys inside CloudHSM. On the KMS side, we handle all the availability, the durability, the management. We ensure that every request is audited. It's integrated with 10 AWS services today. That number will grow over time. And you can use it in the context of protecting data inside AWS services, but you can also use it directly from your own applications. KMS could be the only AWS service you use just to get encryption keys down to protect your data. Okay. So let's say you still don't want to use a service that's offered by AWS. What else can I do? So we have several partners. There are 5 that we work with pretty commonly right now that offer solutions where you can trust them and their software implementations to manage keys and provide those keys to your applications. These vendors all have solutions that can run on top of EC2 in your instance, and they're available via Marketplace, which makes it very easy to provision. But you can also run these solutions outside of AWS and have your applications talk to them. So there's a lot of flexibility in how you run these partner solutions. In the case where they have integrated with Marketplace, they typically offer a pay-by-use licensing fee, but you can also bring your own license in every case. So we don't recommend one solution over another. You need to evaluate them to understand their performance characteristics, what features they have, but they are working at making the deployment of their software easier inside AWS by being on Marketplace. Okay, so the last option you have, which is I don't want to trust anybody, AWS, partner, I just want open source technology. I'm going to manage all the keys myself so I know exactly where things are. Again, perfectly doable, right? You can run whatever software you want and whatever you've written on top of an EC2 instance. You can have your key management infrastructure live wherever you want as long as it's accessible from your application. And we have certainly customers that have done this themselves for very high value, high assurance workloads. And ultimately, you're going to be submitting a piece of ciphertext to an AWS service, typically just for storage. And you can be guaranteed that nobody is going to be able to open that ciphertext until that gets back to an application that you wrote. Okay? So I've got a table here. I'm not going to read through it. For those of you who get access to the slides, it just kind of summarizes the pros and cons of each of these services. Under these dimensions of where keys are stored, where and how they're used, whose responsibility is it to make sure this scales, it's highly available, keys are durable, and what the pricing model looks like. Okay, so we've talked about 4 different options: Key Management Service, CloudHSM, partner solutions via Marketplace, and do it yourself. Okay. So now, at this point, I'd like to bring up Frank Wiebe, who's going to talk a little bit about some work that they did over the past year to solve a data security problem. So Frank, come on up.
Thanks, Ken. Good afternoon, everyone. Just maybe 2 pieces of background here before I get started. So I'm part of what we know internally as the Adobe.io team. We are a DevOps team that's responsible for building and managing and operating an API management platform internally. As part of that, we get presented with many different use cases, and I'm going to walk you through one of the ones that we were presented with about a year ago, actually. It was very convenient that last year at reInvent, Ken actually announced KMS service, and literally it was right outside after that session that outside one of these halls that he and I sketched what we thought was going to be what the architecture and flow would look like for the solution I'm going to talk about this afternoon. So with that, let's kind of delve into what the use case actually is. So one of the things too, if you've been following Adobe over the last couple of years, you may have noticed that we are now starting to expose many more of our capabilities at an API level, perhaps packaged through SDKs. And we also have done a number of acquisitions over this time and acquired other companies that actually have APIs that we've been rolling into our standard SDKs. So the one I'm going to talk about specifically is related to what we call our Creative SDK. This is the SDK that a third-party developer could use to build a mobile app that interacts with our Creative Cloud, to be able to like pull content from Creative Cloud, be able to manipulate images and then store them back in the cloud. So one of the use case that we were presented with actually is that through an acquisition, we were presented with a company that actually stored content in the cloud that they actually charged for. So we needed to find a way that we could somehow secure that call from a mobile application that was being made using the APIs as part of the Creative SDK. And we worked with our security teams and we came up with an approach to saying, well, why don't we use basically HMAC signatures as part of that? So we said we would create a special digital signature using HMACs, whatever. So when the mobile application is making a call basically to the Creative Cloud through the Adobe.io gateway, the gateway would be able to basically validate that signature and actually say, yes, this is a call from a valid customer, it's been properly signed, and then we can then allow the request to go through and have the content be accessed. This was important here because we did not, of course, want to have somebody being fraudulently billing or ringing up charges against somebody else's account. Okay. There we go. So running an API gateway, though, I mean, we currently run hundreds of millions of requests per day through the gateways. So we wanted to be able to find a solution to that would also be highly performant as well as being reliable and auditable and secure. So we know we needed to minimize the amount of time that we kept, the sensitive data, in this case, the secret that's used around in our caches, and we need to be able to protect them. And we also needed to build a solution that would be highly performant based on the number of APIs that we might have to process using that. So we actually architected a solution using KMS and also Elastic Cache for Redis. And using this approach, we were able to convince and show our security team that, in fact, we could retrieve the secret, we could store it securely only in memory or in the shared cache built using Redis, and be able to then validate these HMAC signatures so that we could basically say to our clients, our third-party developers, that yes, you can make these requests and you can be assured that things will be properly done. So what were our requirements around this? Well, because of the fact we needed to be able to share a common secret, a key, with third-party developers, it had to be a symmetric encryption model. So that's one of the requirements. We said our gateways have 4 nines kind of availability. We expected the KMS to be able to have exactly that same kind of availability wherever we were. But we also wanted to make sure we had low overhead and cost. I mean, we were a small DevOps team. We didn't have time, we weren't given the time, or we didn't want to go build our own key management solution. So KMS came along for us just at the right time. We knew in order to satisfy our security teams that we needed to be able to have an audit trail and strong controls around those keys, again, so that we could demonstrate that to our customers as well as our internal security teams. And we needed something that we could get out the door really quickly. We had less than 2 months from the time basically this case was presented to us to actually get it out the door and running in production and have gone through all the security reviews we needed to have. So this again was another reason why we didn't want to build something, and when KMS was announced, this became an immediate solution for what we needed to do. So just a few other little technical details on our requirements. Of course, we wanted 256-bit encryption. We knew we needed high availability and durability related to the keys, and that was consistent with the experience that we've had with AWS as a whole. We needed to be able to show to our security teams that we had the right audit controls, or could say controls and audit trails in place, so that we could actually go back and see who was using keys. And of course, we needed to have fast deployment. We had literally about 4 weeks to get this done at the end of the day within that 2-month cycle, because we had to go through various other reviews. So what does the request look like? So if you look at it as a mobile application, it's making a request to our gateway, and so you got one of these digital signatures attached to that request. So the first thing the gateway needs to do is it needs to first of all look to say, okay, I need to validate this request. I need to say, does it come from somebody that I know and I can identify? And it needs to look up, so it's got this digital signature, so it needs to say, okay, I need to be able to decrypt this. So first thing we do is actually we implemented a two-tiered caching structure, and we actually, for short periods of time, actually do store the keys in what we call the Nginx local cache. Our gateways are all built based on OpenResty, Nginx, and Lua at the core, whatever, so we could basically implement a local cache that would be on Nginx, and then we actually had Redis as, if you wish, the shared cache across all the gateway nodes that live in an auto-scaling group. So the first thing we need to do is, check to see, did we already have the secret that we needed in the Nginx local cache? If we did not, then we would then check the shared cache, and if we didn't have it in the shared cache, we said, okay, we need to go retrieve the secret from our own KMS, not to be confused with the Amazon KMS service. We have to go retrieve the secret, and then we have to basically, at that point, now that we had it, we have to be able to protect it. So we called KMS to generate a data encryption key, and then using that, we then created the deck, and that's what we then used to encrypt the secret. And then we can then store that secret safely inside of our cache, and then use that as part of that to actually validate the digital signature. So by being able to do this, by having the two-tiered cache, we actually had a very high-performant way to be able to take these keys, to be able to get the secrets, store them safely, and we associated a time to live with them as well too, so that these keys would not live forever either in our shared caches, so that after a period of time they'll be automatically flushed out of the cache, and the gateway will have to repeat this exercise. So I got a couple of slides here that show some code. I don't want to have to go through all the nits and bytes of the code because you're going to see this in the slides. But the one thing I do want to point out is that we have actually open sourced our SDK that we used for Amazon and Nginx and Lua, and it's at the GitHub link that you can see here. So if you happen to be using Nginx and Lua, you can go pull our SDK, and maybe that'll be helpful to you to actually start interacting with Amazon-based resources. That's what we built this SDK for. So we use a lot of Amazon services from our gateways. So we decided to just build this SDK, and we've decided to open source it as well. So on this slide, we actually just give you an example of some Lua code here that actually does the encryption. So you can sort of see it's really not a lot of code. It's very, very small. It operates very, very fast. It looks in the cache. If it doesn't find it there, it then goes out, generates a deck, goes and encrypts the key, uses the ciphertext, and we can then store that safely in the cache. So that's, again, so all of this is included in the SDK, and you can go download that if you wish and actually go take a really close look at how we do it. So from our experience, so we went live with this in December of 2014. Since that time, we've had no operational performance issues at all associated with using KMS. It's been highly performant for what we need. We've seen, from our perspective, 100% availability to KMS. And remember, too, based on the way we've architected our system, is that we do cache those encrypted secrets for short periods of time using TTL. So we did create some protection around us in the event that something did happen. We haven't seen that, though. And then really, once we did some of those initial discussions with Ken and then a couple of follow-up conference calls, really the solution basically has been there, designed, running, and basically we haven't had to worry about it ever since. It's been a very smooth implementation for us, and it hasn't caused us any problems over the last roughly 10, 11 months that we've been running it in production. So Ken asked to say, what was our wish list of things that we wanted in KMS in the future? And we're not the only team at Adobe that's actually using KMS. And right now for us, we actually didn't have a specific wish list item, but one of our other sister teams did, and it dealt with the idea of using cross-region replication of encrypted AWS resources. And the fact that master keys can't move between regions, but we sometimes move data between regions, and how can we handle the re-encrypting of that data in a more smoother fashion. So I think with that explains, sort of describes our use case. And if you have any questions, I'd be happy to answer them after. If not, Ken, welcome back.
All right, thanks a lot, Frank. Just to wrap up, you'll get this slide after reInvent when they get posted. A couple things I want to highlight. The overview of KMS is on the aws.amazon.com website. We have a white paper, which is linked off the FAQs there. It goes into quite a bit of detail how KMS is architected. We find that customers like to share that with the IT security group so that you can keep your security teams happy about being able to use KMS. So definitely take a look there. Data or white papers on CloudHSM, overall encryption, as well as some details on some of the SDKs and partner solutions are all available at these links. The security blog at the bottom would be a good place for you to check and subscribe to. From time to time, we have customer use cases about how they solve the data security problem using encryption with one of the solutions we talked about. So right after this, I highly recommend you guys head upstairs and listen to John Todd from Okta talk about how they're using KMS inside their application to protect their customers' data. I think you'll find it a very compelling presentation. It's a 400-level session, so you'll get lots of good detail. 2 other sessions that I believe may have already happened, but just for reference, if you're going to look at the videos on YouTube when they get published, the EBS Deep Dive, which talks about how they do encryption of resources, and then how the EMR and Redshift services can protect your data for big data applications. Okay, finally, remember to complete your your evaluations. For those of you who have questions, Frank and I will be over there. I'd also like Matt and Andrew here in the front just to raise your hand. Those two can also be available there with AWS Cryptography. We'll be out on the hallway while we recycle the room for the next presentation. Okay, thank you very much.